Hi everyone, welcome to another ThermublastMQL installation video. It's a little bit different to the normal ones. Normally I try and rush it through and get it all installed in 1 minute. This is going to take a little bit longer because I'm going to give a brief explanation of how Thermublast works and what the plan is and how it's supposed to do. So it's actually called ThermublastMQL because it's a minimum quantity lubrication. It's not flood cooling, it's not mist cooling, which is spray mist into the vapor in the atmosphere. It's a pulsed liquid cooling and lubrication. It's pulsed air blast chip clearing as well. So we have a little microprocessor in here which actually allows us to set the liquid cooling profile, which is the number and duration of pulses of coolant, and a chip clearing profile, which is the number and duration of pulses of blasts of air. And we have separate regulators here to set the air pressure to deliver the coolant, which is about 1 to 2 bar. There's a label that tells you that. And there's a separate regulator here which sets the pressure for the blasts of air to do the chip clearing profile. Chip clearing is very important when you're doing pockets and things because you don't want to clog the cutter up, do you? Once you've set the regulators and they come preset, once you set them in detail yourself, you're never going to adjust them again. So there's no worry about adjustments there. So as I say, computer system with a display and the little keypad. You can set and store the profile for the chip clearing and for the lubrication, and then a 1 litre reservoir which we draw through a set of valves. First valve is for the liquid, the white tube. Second valve is the blue tube is for the propelling air for the liquid, and the final one, a black tube, is for the air blast pulses. These come to a mixing block all the way through a lock line to direct the flow to an actual nozzle at the end, with 2 tubes. The actual air blast nozzle is directed down at an angle such that it meets the liquid at about 30 to 40 mils from the end of the nozzle. So that's the basics of what you get supplied with. And you also get supplied with a rail system to actually allow you to move it back and forwards. So if you can actually have the whole thing mounted on here, fine, but we could mount the mixing block separately if we wish. We could put magnets on the back of it and mount it separately and have longer lines. You get it with 1.2 meter lines, 3 tubes 2 meters long, and you can cut them down accordingly. You also get the power supply which is required to run this system, which is a 12 volt unit you plug into the wall, but you don't get compressed air. You'll have to stick an 8mm tube in to supply the compressed air. So in the usual way, I'll now actually pop Thermublast onto a bracket and switch it on. So in this case, we have to actually mount Thermublast onto the machine physically, and what we're doing is we're using this universal mounting plate, which you've probably seen in a lot of other very short videos, not a long one like this one. It's got 3 bosses and there's 3 key slots in the back plate. We simply present it on and it slides down, locks in position. There's no real play, it's nice and stiff. Now the bracket which I'm using is one from our range. Much easier to use a bracket which you don't have to prepare your own. It'll take your slavering on. And this bracket actually mounts without any holes in the milling machine at all. We use the 3/4 UNC lifting eye bolt hole, which is already in the top of the casting on most of these sort of size of Bridgeport style vertical milling machines. So it actually, you come with a fit and goes straight through some extrusion, and there is 2 axes of extrusion, so we can actually rotate this round and it gives a nice firm fixing. So I'll pop it onto the plate in the usual way. Ta-da! Doesn't take very long, does it? So now it's on the bracket. I have to connect the services of air and electricity, which I normally do like this, and this regulator block side. Switch the air on. I have a 12 volt power supply just plugged into the wall, which is connected up here, which goes to this connector here. Oops. Now you'll see that the light has come on the nozzle, which indicates that the power is connected to the main unit. I then rotate. I just bring it round. When it comes to a stop, the rail touches the side casting of the machine. Right, we direct the nozzle towards the job, not to the tool, but down to the job, and obviously the tool will follow that when it's in use. So if I switched it on now, immediately it'll dispense liquid, and it's dispensing at the default profile for cooling and chip clearing. The cooling profile I can see is 2 pulses of liquid. In fact, 0.1 of a second pulse of liquid, then 1 pulse of air, very, very short pulse of air. I could actually change that. The pulses are 0.1 of a second at the moment. I could make them up to anywhere from 0.1 to 0.9 of a second. So if I increase them, if I just increase them to 0.3, you'll see it's quite a dramatic change. No, it's not thrilling, but there's quite a lot more liquid there, isn't there? And I could just as easily increase the number of pulses like that. Now it's almost continuous liquid, but that's a lot of liquid just to drill a hole. So I'll put it down a bit. I don't need anything like that. And I'll put it back down to 3 pulses. So now I'll actually change the air blast profile, which is the chip clearing part. There we go. At the moment it's a 0.1 of a second pulse. I'll increase it to 0.3 and I'll give it 3 pulses. There's a lot of air blast clearing there. Now, the chip clearing function is really as fundamental as the lubrication function. If you're making a pocket or milling a big slot, you've got to get rid of the cuttings so you get a rubbish finish, as we all know. And in a deep hole, you've got to get rid of the cuttings as well. You've got to make sure that nothing's getting stuck in around the cutter in the hole. But once again, I'll actually reduce it down a little bit for practicality. And now I actually drill the hole. All right. I'm drilling a 5mm hole in a stainless steel shaft. And it's 22, 23, 25 mil deep. It was already drilled 10 mil deep, I can see that. And this in fact is the shaft which is the reel to mount the mixing block on. So there we have it, a little bit more detail of how Thermublast actually works, and drilling a hole in a part, nothing exciting I'm afraid. Hopefully that's of some use to you, and I'll catch you in the next one. Bye bye.